In the first video, I taught you a game. In the second video, I gave you a hint. In the third video, I showed you the trick to winning the game. And in the fourth video, I showed you how you might have figured out the trick. But good math isn't about tricks, it's about methods. And what is a method but a trick that works more than once? So let's apply the place value method to another problem. In fact, let's apply it to the variant of swine in a line that I introduced in the third video. I'll remind you how it goes. When it's your turn, you add a pig to a pen, and then carry out the consequences. When there's a pen with two or more pigs in it, one pig goes one pen to the left, and the other pig goes back into the field. When every pen has at most one pig in it, it's the other player's turn. Maybe your adversary just goes there, and then it's your turn again. You win if you put in a pig that fills up the board with one pig in each pen. You lose instantly if there are ever two pigs in the leftmost pen. For instance, this way. Put a pig here. One goes left, and one goes out. Oh, two pigs here. Game over. As in the original version of the game, making a move can lead to a confusing chain reaction of consequences, but remember one of the things I said in the fourth video. There's got to be stability amid the apparent change. Let's apply that motto here. When there are two pigs in the same pen, and one goes left and one goes away, what doesn't change? What's the conserved quantity? As in the earlier video, we'll try to come up with a conserved quantity using the idea of place value. The value of a configuration of pigs is the sum of the values of the pigs in the pens, where the value of a pig is determined by what pen it's in some fashion we have yet to determine. If pens 4, 5, and 6 have the as yet unknown values x, y, and z, then we want x, y, and z to satisfy the relation z plus z equals y, representing the fact that when we replace two pigs in pen 6 by one pig in pen 5, the total value of the pigs isn't supposed to change. We also want x, y, and z to satisfy the relation y plus y equals x, representing the fact that when we replace two pigs in pen 5 by one pig in pen 4, the total value of the pigs isn't supposed to change. So, to make our place value system work, we need x to be twice y, where y in turn is twice z. That is, the values x, y, and z must be in decreasing geometric progression, with each value being twice the next. This applies to all 9 pens, not just the 3 in the middle. The most natural solution is to decree that a pig in the rightmost pen has value 1, a pig in the next pen over has value 2, a pig in the next pen over from there has value 4, and so on, up to the leftmost pen, which has value 256. That is, the values of the pens from right to left will be the successive powers of 2, starting from 2 to the power of 0 and ending with 2 to the power of 8. By now, you've probably recognized the shabby pedagogical trick I've pulled on you. This is just the binary system for representing numbers disguised by pigs. This, for instance, is the binary representation for the number 17, 2 to the power of 0 plus 2 to the power of 4. When you add a pig to the position your opponent has given you, you increase the place value of the position by a power of 2. If this leads to some pen containing more than one pig, there will be consequences, but those consequences won't change the place value of the position. So you can think of this game as a numbers game, where the goal is to be the player who gets to a position whose place value is 511. That's the sum of the first 9 powers of 2, starting from 2 to the 0th power and ending with 2 to the 8th power. Notice that in this game, place value never goes down. It only stays the same or goes up. Also notice that if a player makes a move that causes the place value of the position to be 512 or higher, the consequences of the move will trigger the sudden death rule. We'll get to a situation in which there are two pigs in the leftmost pen, causing the player who made the move to lose instantly. So this is really a game about adding powers of 2 to a running total without ever overshooting 511. You might want to stop the video here if you haven't already completely solved the game. Are you ready for the answer? The kind of position you want to move to when it's your turn is a position whose place value is one more than a multiple of 3, a number like 1 or 4 or 7 or 10, ... all the way up to 505 or 508 or, best of all, 511. If that seems too complicated to do in your head, here's a different way of achieving the same goal. Instead of using place values 1, 2, 4, 8, etc., use place values 1, 2, 1, 2, etc., or plus 1, minus 1, plus 1, minus 1, etc. Also, instead of adding the values of the pigs in the position that your opponent has given you, add the values of the empty pens. If it's a multiple of 3, you have no winning move. Otherwise, it tells you what pen to play in on your turn. There may be several winning moves. For instance, starting from this position, there are 4 winning moves. They increase the value of the position by 2 to the power of 1, 2 to the power of 3, 2 to the power of 5, and 2 to the power of 7, respectively. Just be careful not to move to a position whose binary value exceeds 511. You can find more details on the Barefoot Math blog. Another place you can learn more about this game and the earlier one goes left, one goes right version of Swine in a Line is my monthly Mathematical Enchantments blog. As I mentioned there, one inspiration for these games came from the theory of sandpile groups. And if you like these videos, you'll definitely want to check out Brady Haran's number file video on sandpiles. But even more importantly, I urge you to check out James Tanton's Exploding Dots videos. My jumping pigs are really just exploding dots that oink. Tanton uses his dots not just to explain binary arithmetic and ordinary decimal arithmetic, but polynomial arithmetic as well. And exploding dots are poised to explode all around the world in late 2017 thanks to the Global Math Project, which is going to share this beautiful way of doing math with 1 million or more children around the world during Global Math Week. What I've tried to convey in these 5 videos is the way place value can crop up in situations where you don't expect it. By packaging the mathematics of place value inside a game, I hope I've created an activity that fits alongside Global Math Week for kids who really like the dynamic appeal of exploding dots and want some playful, sociable, hands-on follow-up activities that let them take things a step further. That's all for now. Thanks for listening.